Thunderstorms are some of the most extreme phenomena on the entire planet, and they actually require a very specific set of conditions in order for them to develop. The first is that storms need moisture. Without moisture in the air, we can't have anything. So there has to be some form of water vapor, something that the storms can actually use to go ahead and develop from. The second thing is instability. Now, instability is not always present, but in severe weather, or whenever there's thunderstorms forming, when the air becomes unstable, it means it wants to lift, and it wants to keep lifting higher and higher and higher. And what that essentially means is there is warm, moist air near the surface of the earth, and as you go up, it becomes cold and dry. And the greater the difference in the gradient between the warm air and the cold air, the greater the instability. So the colder that the air can be in the atmosphere, the more unstable the atmosphere is going to be. From that, we're going to get a lot of lift. The air is just going to want to go and keep rising and rising. And that's a sign for thunderstorms. The third thing relates to this directly. It's called a lifting mechanism. Now, we have the unstable air, which of course is going to rise, but we need a trigger. There's got to be something that causes the air to want to lift. And one of those things are fronts. A cold front, for example, it has cold, dry air behind it, warm, moist air ahead of it. And because the warm air is much less dense, it's going to rise. Behind the front, the air is freezing. Well, not always freezing, but it's a lot colder compared to the air in front. So that cold air is sinking and forces the air in front to rise. We get the kind of motion in the atmosphere. We have unstable air with a lifting mechanism, plenty of moisture ahead. We're going to get thunderstorms to form. You get that cumulonimbus formation at the top of the cloud. Eventually, the air will stop. It's called the tropopause. And at that point is when the cloud levels off. And you'll notice a cumulonimbus cloud grows really tall, but then eventually it stops and it grows outward. And that's the force of the updraft within it. As the air moves up into the storm, it can't go past the tropopause, otherwise it enters the stratosphere. So at the tropopause, the wind essentially goes from roughly vertical straight to horizontal, and the cloud shoots out. We call that part the anvil. And for those of you who know a little bit about lightning, the main dangers of lightning is that the lightning can strike from that anvil and end up miles outside of the storm. So not all the lightning from a cumulonimbus cloud comes from the big center part. Sometimes it can hit you when you least expect it from that anvil, which is extremely dangerous, also kills the most amount of people. So that's a rough explanation of severe thunderstorms, cumulonimbus clouds in particular, and hope you got a lot from that.